Welcome back. In this video, we are going to learn about a new kind of market environment, that is monopoly. Before we do that, I would like to go back to perfectly competitive market environment, and we will take a look at the lesson learned in that context. Why it is important that we look back? It is going to help us in two ways. One, it will help us compare this new market environment, that is monopoly, with a market environment that we already know, that is perfectly competitive market environment. Second, some of the results that go through in perfectly competitive market environment will also be valid here, and one of that is profit maximizing condition. So, how do we get the profit maximizing condition? We say there is a firm, and firm is typically interested in maximizing its profit. Profit is nothing but total revenue minus total cost. And we see that if we change Q or we decrease Q, there will be a change in total revenue, and that change can be given by marginal revenue. And similarly, there would be a change in total cost, and that change, because we are changing Q, let us say by 1 unit, so a change here will be equal to MC. If it is greater than 0, it's good idea to increase Q. Okay, it's greater than 0, increase Q, less than 0, decrease Q, and equal to 0, I think that can be the ideal scenario. This MR is equal to MC condition still goes through, but there is a catch. And what happens in perfectly competitive market, that everyone is price taker. All the firm have absolutely no control over the price. They take market price as given, and therefore if they sell one more unit, their revenue goes up by P. Or if they sell delta Q unit, their revenue goes up by P delta Q, and therefore marginal revenue is going to be P delta Q divided by delta Q equal to P. So, marginal revenue is equal to P, or P is equal to marginal revenue. We will see this is not the case when we talk about monopoly. This is no longer the case. So, that is a difference. But nevertheless, we keep in mind that MR is equal to MC remains a profit maximizing condition, whether we are talking about a firm operating in perfectly competitive market environment or a monopoly firm. Pretty soon we will come to notion that what is monopoly, but bear with me for a few minutes. Next point I want to make is about market demand. Of course, when we talk about market demand, typically we have figured out that on graph we give P as a function of Q, but algebraically or in form of equation we write Q as a function of P, and this we get as market demand. We have also learned about Marshallian market demand. How do we get the Marshallian market demand? My aim is also to revise a little bit. Marshallian market demand is that each consumer in the market does utility maximization and figures out how many units he or she would buy at each of these prices, and when we add up all the consumers, we get the market demand if we figure out quantity demanded at each price. So, that is how we get it, and this remains the same market demand, because when we talk about market environment, basically the variation is coming on the supply side. So, on in perfectly competitive market environment, all suppliers are price taker. Okay. So, the difference is on the supply side, there is no difference on the consumer side. So, market demand is still a downward sloping curve, and that is same in both the cases. But now there is a change. Each firm in perfectly competitive market takes price as given. So, their demand, the demand curve that they face is very perfectly elastic in a way. This is the way it looks like, this is P star. They can supply any quantity at P star till they reach to the quantity demanded by all consumer at Q star, and below P star they will follow the curve, the market demand curve, and if price is higher than P star they don't see any demand. So this is what is faced by a perfectly competitive firm. So that's what we should keep in mind. So again let me repeat, when it comes to market demand, a monopoly and perfectly competitive firm, they see exactly the same market demand. But now when we talk about a particular firm in perfectly competitive environment, it has perfectly elastic part in the demand curve that it faces. Now the next is economic profit and supply in short run versus long run. What did we figure out? That in short run firms can make some profit, but as you know, when we talk about this profit, what we mean is economic profit and we do not mean the accounting profit. So it's very much possible that a firm operating in perfectly competitive market can make positive profit or a loss in the short run. If firms are making positive profit, more firms will enter the market, and in the long run economic profit will become equal to 0. So in short run we can say what we have here is P is equal to, let's say it's P, that is price, is equal to MR is equal to MC. That's what we will get here. In the long run what happens, because there is no profit opportunity, so MC it becomes equal to AC. So in the long run we have P is equal to MR is equal to MC is equal to AC. And on consumer side, what do we get? At this, let us say if this is the price for the good X, so then we also get MPX, or sorry, MUX, because marginal utility we should be writing here. Let me say here, the marginal utility Px is equal to MUY Py, and we are assuming that this person is spending positive amount on good 1 as well as positive amount on good 2. So this is what you will get. And we have also figured out that in short run the supply curve is upward sloping part of marginal cost curve that lies above. Let us say this is the marginal cost curve, and let us say this is, this is, let us say this is average cost curve, then the supply curve is going to be this upward sloping part that lies above the average cost curve. And we can say very well this is average variable cost curve, because in the short run what is interesting is that we have to worry about average variable cost. In long run we have to talk about average cost curve, but these things go through. So that is the basic understanding we had from perfectly competitive market environment. Another thing that we figured out in perfectly competitive market environment, that we have what we can say, that how the price in the market is determined, that you can look at the demand side of the story, you can look at the supply side of the story. This is supply, this is the demand, and what we get is this is the P star, this is the Q star, and all the firm would be, if this is the demand curve, let us say this is the demand curve, let's say this one and this one are the same, then we can say, as I had already alluded, that P star, this is going to be the demand curve that one particular firm faces. And we had also figured out in this particular setting that this is consumer surplus CS and this is producer surplus. And we kind of see this is the maximum social welfare that can accrue to the society, that can come to the society. That's what we had figured out. Now, we are going to study monopoly, and we should be comparing monopoly with perfectly competitive market environment. First of all, what is monopoly? So, first, in theory, monopoly is simply that you have one seller and many buyers. That's important. What we want to say, that buyers are price taker, they cannot influence the price, but and the seller, the lone seller, is the price maker. The lone seller decide how much should be the price of its product. Can he decide randomly how much should be the price? Can he put prices as high as possible? No, because remember, buyers, they do not have control, but what they have is a downward sloping demand curve that looks like something like this, PQ. So, if monopolist puts a very high price, let us say here PH, the quantity demanded is going to be QH. And if it puts PL, then quantity demanded is going to be QL. And so, we can see, of course, this monopolist would be doing the profit maximization. Just look at it, when it has price as PH and it sells QH, this is the quantity, this is the total revenue that it should be getting. And of course, we have to look at profit, we have to see that TR minus how much is the cost to manufacture QH. And if it has lower price, this is what it captures as total revenue, the profit is going to be, let us say, TR low minus CQL. Of course, it had to figure out that whether it wants a high price or low price. Of course, here I am just comparing a high price with low price, but in fact there is a possibility that it can have any infinite level of pricing. It can decide which one to keep. It will come from profit maximization. But the thing that you should understand, the monopolist faces volume versus margin trade off. If the price is very high price, what we can say that margin, what is margin? Profit on each item. Margin is going to be high, but volume is going to be low. And very low price, margin is going to be low, but volume is going to be high. And what you care about is margin multiplied by volume, isn't it? This is Q and this margin is P minus AC. And so, basically if you write P minus AC multiplied by Q, PQ minus AC multiplied by Q, this is your total revenue, this is your total cost. You are back to the original equation. So, there is a trade off that one can do. Now, so the take here is, theoretically speaking, that we have just one buyer and many sellers, but in practice this is way more difficult to achieve. Why? You know, think of any industry. You may have industry dominated by a large firm, but there would be also many small firms producing similar good. You know, for example, at one point of time in laptop, the Windows had 90 to 95% market share, but some people were buying Mac, Linux. Over the period, number of Mac buyers has increased significantly. Similarly, in diamond industry, we had De Beers, the only main diamond seller, but then again there were tiny small firms also selling diamond. So there is of course difference between theory and practice. In theory we of course say that one firm and many buyers. In practice, it's possible that we have more than one firm, but still we can approximate it as a monopoly firm, and that we will learn over time. We will see. I will give you an example which we can see that how we can approximate the market using monopoly better than using perfectly competitive market. What is the idea? Also, please understand, when we say that only one firm is selling the good, then the way we define the good becomes very important. Like for example, if you think of a flight from Delhi to Kanpur, and I keep on giving example from Kanpur as I am from Kanpur, IIT Kanpur. If you think from flight from Delhi to Kanpur, there is only one Indigo flight. Can we say that Indigo is monopolist because there are many people interested in traveling to Kanpur using Indigo flight? I would not say so, because when you want to come to Kanpur from Delhi, you can also take train. No, Vande Bharat takes these days approximately 4 hours or 4 hours 30 minutes. Indigo will also effectively take, if you add the time you take to reach the Delhi airport and waiting and security check and on, it will also be in the ballpark of 3 to 4 hours. And of course, people can also take car. So the Indigo flight would be competing against the train and would also be competing against the travel by car, may not be competing against travel by bus. So you have to be very careful how you define the good. It's just the flight or travel from Delhi to Kanpur. If you define the good very narrowly, then you will get less number of firm operating in the market. If you define your good very broadly, then of course you cannot get monopoly. So that is a very conscious choice that you have to make. That's a modeling technique that you have to figure out that which way you want to go. So we can say that for monopoly the requirement is that good should not have a close substitute. Okay, because if close substitutes are available, price goes up, you would shift to other item. Okay, so that's what you have to keep in mind. So please understand what's happening with the monopolist. The monopolist, theoretically speaking at least, that there is only one firm in the market and that is facing a downward sloping curve. Okay, P and Q. And so remember, when we talked about perfectly competitive market environment, we said that a particular firm would see demand like a perfectly elastic part and then following the market demand, and at price above P star, no demand at all. But think about the monopoly firm. If this is the market demand, this is also the demand curve that the monopolist firm faces. There is absolutely no difference. Okay, so I hope you understand the difference between theory and practice. Even if you have more than one firm in practice, you can sometime model it as a monopoly, and that we will see later on, perhaps in this video or next video, depending on the length of the video. I will cut it either in this or in the next video. So let us first try to understand theoretically. Let us say this is the market demand. Again, what does it mean? That Q is equal to 10 minus P if P is between 0 and 10, and 0 if P happens to be greater than 10. In other word, we can write that Q is equal to max 10 minus P comma 0. This is the demand function. And so if we want to write, we can say here that let us fill number in this particular table. So Q can vary from 0 to 10. There is no point going above 10 because maximum Q possible is 10, because 10 is the reservation price for, I think, highest pair in the market. So we can write here 3, 4, 5, 6, 7, 8, 9, 10, and then P of course is going to be here 10, 9, 8, 7, 6, 5, 4, 3, 2, 1 and 0. And we can obtain PQ, which is nothing but total revenue, and total revenue is going to be 0. It's going to go up. PQ is simply multiply these two number, multiply these two number, and this is what you can get. And from here you see it starts decreasing, and then again it is decreasing, and then this is equal to 0. And how can we obtain marginal revenue? Let us use our rudimentary definition, not the perfect definition, that if we increase Q by 1 unit, how much is the change in total revenue? Here is 9, here is 7, here is 5, here is 3, here is 1, and then it goes minus 1 because from 25 it's becoming 24, minus 3, minus 5, minus 7 and minus 9. And 2Q, which is nothing but its total cost, here it is given. So we have to look at Q and multiply it with 2. So 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. For example, here is 6. I multiply it with 2, I get 12. And again, I can calculate MC by change in marginal cost. If we subtract 0 from 2, we get marginal cost here. Of course, this is an approximation because we are using approximate result. So here everywhere it is equal to 2. Everywhere it is equal to 2. So where do we get MR is equal to MC? If we look at the table, nowhere, but approximately this is happening here, somewhere in the here, because we can see how MR is changing. MR is falling, it's falling, and then it starts in, MR keeps on falling everywhere. Sorry, my mistake. MR keeps on falling linearly, it's falling everywhere. MR is decreasing like this. It's going like this. So where it is equal to 2, somewhere in this vicinity it is equal to 2. So we can say from here it is 4.5, but that's not exact good result, because we will see if we use better definition of marginal revenue, we will get a better result. And what is the better definition of marginal revenue? We can write here, we have P is equal to 10 minus Q. So total revenue is going to be 10 minus Q multiplied by Q. If you draw it, it is a quadratic equation. Total revenue here, Q here, it's going to look like this. This is 0, this is 10, and this is going to be equal to 5. And so if you calculate the marginal revenue is derivative of total revenue with Q, which is, let us say, D 10Q minus Q square dq, and this will come out to be 10 minus 2Q. So if I say here, let us draw the demand curve. Demand curve is 10 minus Q, marginal revenue curve is going to be 10 minus 2Q. By the way, this is not only the demand curve, this is also average revenue curve. So if total revenue is P by Q, average revenue is going to be TR by Q. This is average revenue. So PQ by Q, and you are left with P, which is nothing but 10 minus Q. So this is the demand curve as well as average revenue curve, and this is your marginal revenue curve. This is marginal revenue curve. And then of course you have total cost as 2Q, and so marginal cost is going to be equal to 2, which is everywhere it is same. So we can draw it like this. This is equal to 2. And so this is where, because this curve is marginal revenue curve and this curve is marginal cost curve. So this is where they meet. We can also figure out from equation that 10 minus 2q should be equal to 2. So q should be equal to 10 minus 2 divided by 2, which is equal to 4, and this is 4. And if q is equal to 4, p has to be equal to 10 minus q star, which is, we can say p star, which is 10 minus 4 is equal to 6. And this is the way you have to see that at 4, if quantity that monopolist is selling in the market is 4, how much buyers are willing to pay per unit? You have to go back to the demand curve, and this they are willing to pay is equal to 6. Okay, so equilibrium q star p star is coming out to be 4 comma 6. If we go to the previous slide, it was somewhere in the middle of this, but in fact it turns out to be this is where you are getting the optimal quantity. So that's what you have to keep in mind. Now also understand that if this was the marginal cost curve is 2 everywhere, so we can say supply is elastic. At price of 2, firm, this firm, if it was operating in the perfectly competitive market, it would have been willing to supply any quantity at price 2. So perfectly elastic supply, this is 2. And how much is the market demand? Market demand is coming out to be 10 minus q. So what would be the competitive quantity? Competitive quantity is going to be 10 minus q is equal to 2. So we can say q star c, and we can put here m to indicate that this optimum is coming for the monopolist. Q star c is 8, and if q star c is 8, p star c is simply going to be equal to 2. Okay, so see the difference, that q star c comma q star p star c, which is competitive equilibrium, is 8 comma 2. So monopolist would produce less amount and sell it at higher price, and this is what we will try to understand with a general example.